Hello, all. Welcome to the class of Discrete Mathematical Structures. 18CS36 is a subject code. Today I'll be teaching a topic in Module 3, Relations and Functions, and the topic name is Composition of Functions. Myself, Dr. Madhura, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology, Bengaluru. First, let us see the definition for composition of functions. Let A, B, C be any non-empty sets and f be a function from A to B and g be a function from B to C. Then the composition of these two functions is defined as G composition F. A small circle in the middle is read as composition. So the composition of two functions is defined as G composition F, which is a function from A to C, with G composition F of A is equal to G of F of A for every A belonging to the set A. So we define composition of functions on a particular element of A, where A belongs to the set A, and G composition F of A is given by G of F of A. Note, suppose f is a function from A to A, and f power 1 is nothing but f itself. F square is obtained by f composition f. F cube is obtained as f square composition f. We can obtain different powers of f by making use of the definition of composition of functions. Secondly, suppose f is a function from A to B and g is a function from B to C, then the following are true. First one, if f and g are one-to-one functions, then g composition f is also one-to-one. Two functions f and g, if they are one-to-one functions, then the composition of two functions is also one-to-one. Secondly, if G composition F is 1 to 1, then F is 1 to 1. So these are some of the properties which we'll be in need of while we take up the problems. So suppose G composition F is 1 to 1, then F is said to be 1 to 1 function. Third one, if F and G are onto, then G composition F is also onto. So from first and the third one, if f and g are 1 to 1, then g composition f are also 1 to 1. If f and g are onto from the third one we are talking, then g composition as f will also be onto function. If g composition f is onto, then g is onto. So these are some of the important points that we have to know if f is a function from A to B and g is a function from B to C. Next, suppose f is a function from A to B, g another function from B to C, and h is a third function from C to D. Then we are trying to look into composition of three functions. So which is f composition g composition h is given by f composition g composition h. So the associative property holds good for composition of three functions. Then the fourth point says that the composition of two functions is not commutative. So if you have g composition f, this is not equal to f composition g. So these are some of the important points that we have to make a note while doing problems under composition of functions. So let us do problems now. So let us do problems now. Problems on composition of functions. Problems on composition of functions. First question, let f be a function from a to b, g be another function from b to c, and h be another function from c to d, be three functions, then prove that H composition G composition F is equal to H composition of G composition F. So this is the same as the property what we learned in the theory, but we are asked to prove it. Means the associative property is satisfied for composition of functions is what we have to prove. So let us see the solution for the same. Solution. Now we observe that f is a function from a to b, g is a function from b to c, h is a function from c to d. So we have h composition g composition f or h composition of g composition f will all be functions from a to d. It's a kind of transitivity property application way of understanding we can apply. So A to B, B to C, C to D. So when we take H composition, G composition, F, irrespective of the brackets, it is a function from A to D. So we'll just mention the same thing first. Since F is a function from A to B, G is a function from B to C, and H is a function from C to D. We have both H composition G composition F and H composition of G composition F are functions from A to D. A to D. So now let us take any element x belonging to the set A. So for any x belonging to the set A, we consider the LHS part, that is H composition G composition F on the element x. H composition G composition F of x we are considering. So this can be written as H composition G of f of x. From the definition of composition of functions, this can be written as H composition G of f of x. Now suppose we assume f of x as y, then this can be written as H composition G of y, where we are assuming y is equal to f of x. So assuming y is equal to f of x, this can be written as H composition G of y. Now again applying the definition of composition of functions, this H composition G of y can be written as H of G of y. And this can be written as H of, say, function z, where we have assumed z is equal to G of y. G of y. So we have arrived at the LHS part, that is H composition G of composition of f of x is H of z. Let us assume this as equation 1. So in a similar manner, we will do the RHS part now. In the same manner, we proceed and we do the RHS of the same way. We consider the RHS H composition of G composition of f, G composition f of on the element x. We have taken the element x from the set A. So this can be written as H of G composition f of x. This is again from the definition of composition of functions. We have a composition function outside, no? So we apply that within a bracket. We can just replace it and write down the definition. So h of g composition f of x, we can write it down. So again, applying the composition of definition function again for g composition f of x, this can be written as h of g of f of x. And this in turn is equal to h of g of y. Because we have assumed f of x is equal to y already. What we assumed in the case 1 or the LHS part, that is f of x is equal to y, the same is applicable here also. So f of x is taken as y, so we can write it down as g of y. And what is g of y? G of y is assumed as z. So this can be written as h of z. H of z. So we call this as equation 2. So from 1 and 2, we observe that both are equal to h of z only. So since the RHS are same, we can equate the LHS. So therefore, we have h composition g of composition f of x is equal to h composition of g composition f of x. Reading way it is one and the same, but while writing the brackets, we take care of this. And this is for every x belonging to the set A. Therefore, we can conclude for h composition g of composition f is equal to h composition g composition f. Okay, so I'll just remove this bracket here. This bracket is not applicable. Yeah. Right. So this is composition of three functions is associative. So we have arrived at the required answer. So thus we can conclude that composition of three functions is associative. So that is how we prove the resultant that composition of three functions is associative. The same question can also be asked in the alternate manner, that prove that if f from a to b, g from b to c, and h from c to d are three functions given, then prove that composition of three functions is associative. In that way also the question can be asked. If so, also the way of proving is the same thing. Okay. Let us see the second problem now. Second one, let A be the set given as 1, 2, 3, 4, and B be another set given as A, B, C, and C be the third set given W, X, Y, Z, with F being a function from A to B, and G is another function from B to C. Given by these two functions are given for us. So F is equal to, the elements are 1A, 2A, 3B, 4C, and G can be given by AX, A comma X, B comma Y, C comma Z. Find G composition F. So it is given f and g are two functions defined for us. F is a function from a to b and g is a function from b to c. The sets a, b, c are given for us. And the function f is defined with the ordered pairs 1a, 2a, 3b, 4c. Similarly, the function g is also defined ax, by, cz. We have to find the composition, g composition f we have to find. Okay, so from the data, first let us analyze the data, and we will be able to write down how are the values of function f and g are obtained. Each of these elements in the function f are of the form x comma y, x comma y, x comma y. They can be read in the ordered pair form x comma y in each of these cases. So when I want to write it down as with respect to the function f, right? So I can write down f of 1 is equal to a. F function is defined on each of these elements. So I can write down f of x is equal to y format. So f of 1 is equal to a. Similarly, f of 2 is equal to a. F of 3 is equal to b. F of 4 is equal to c. Similarly, for the function g, we will be able to write down g of a is equal to x, g of b is equal to y, and g of c is equal to z. So this is one of the easiest way of analyzing from the given functions f and g. So let us first write down that by data f of 1 is equal to a, f of 2 is equal to a, f of 3 is equal to b, f of 4 is equal to c. We also have g of a is equal to x, g of b is equal to y, g of c is equal to z. So we have analyzed this from the data and written it. Now, since f is a function from a to b, f is a function from a to b, and g is a function from b to c, g composition f will be a function from a to c. This is from the definition of composition of functions. So we have to find out g composition f means we have to write it down in the ordered pair form what we have seen the function f and the g. In the same manner, we should be now able to write down g composition f. So to obtain that, we now obtain g composition f on all the elements of the set A, because g composition f is a function from A to C. So we have to apply g composition f on all the elements of the set A. So we will do that one by one. So therefore, g composition f of 1 is equal to, set A has the elements 1, 2, 3, 4. So we will do one by one. So g composition f of 1, I am taking the first element, that is 1. So we have, this can be written as g of f of 1 from the definition of composition of functions. We can write it down as g of f of 1. F of 1 value is a by data. So this is g of a, and that in turn g of a value is equal to x. Similarly, we do it for g composition f on the second element of the set A. G composition f is from A to C. So all the elements of the set A, we have to do the composition. So we are taking one by one. So now we will take g composition f of 2. This can be written as g of f of 2 from the definition of composition of functions. F of 2 value is a. So this is again g of a, which is x. F of 2 value by data is a. So that is the reason we write down a here. And we have g of a. G of a is nothing but x. Next, third one, g composition f of 3. So this is g of f of 3. So this is g of f of 3 is b by data and g of b is y by data. F of 3 is b from the data. So we have g of b. G of b is y from the given data. And finally, g composition f of 4. So g of f of 4, which is one and the same as writing g of c. G of c is z. And did you observe the output resultant values x, y, z? They all belong to the set C. X, y, z all belong to the set C. So that is why G composition f is a function from A to C. So on all the elements of the set A, we are applying G composition F, and the resultant values will be, or the elements will be from the set C. So we have obtained the values. Thus we will conclude what is G composition F then. G composition F will be in form of ordered pairs we are trying to write down. So G composition F of 1 is X. So this can be written as 1 comma X. Similarly, G composition F of 2 is also X now. So we can write down the second ordered pair as 2 comma X, 3 comma Y, and lastly 4 comma Z. So this is the answer for G composition F, given F and G as the functions and given the sets A, B, C for us. Now we will take up the third problem. In the third problem, the function f and g are defined for us and G composition F is also defined. We have to determine the constants involved in the functions f and g. So let us see the third problem. Let f and g be functions from R to R, where R is nothing but a set of all real numbers defined by f of x is equal to ax plus b and g of x is equal to 1 minus x plus x square, full stop, if G composition f of x is equal to 9x square minus 9x plus 3, determine the constants a and b. Determine a and b. So let us see how to do the problem. Again, based on the definition of composition of functions, we will be proceeding to do the problem. So solution, it is given that G composition f of x is equal to 9x square minus 9x plus 3. Now from the definition, G composition f of x can be written as G of f of x. So G of f of x is nothing but 9x square minus 9x plus 3. But what is f of x given? F of x is given as ax plus b. Ax plus b. So this can be written now as G of ax plus b is equal to 9x square minus 9x plus 3. So G of, I substituted for f of x as ax plus b. So G of ax plus b can be written as 9x square minus 9x plus 3. Now this is G function now for us. How is G function defined? G of x is defined as 1 minus x plus x square. So if you have x, you are writing it in the form 1 minus x plus x square. In place of x, I have ax plus b. So wherever x is there, I will replace x by ax plus b and write down the G function, which is applicable in the left hand side. So this can be written as 1 minus of ax plus b plus ax plus b the whole square is equal to 9x square minus 9x plus 3. Were you able to follow this? So we have ax plus b. In place of x, we have taken ax plus b. So function is defined, G function is defined as 1 minus x plus x square. So 1 minus x, in place of x, I have to replace by ax plus b plus ax plus b the whole square. Right? So let us expand the square term, a plus b whole square formula. Applying that formula, we will expand this whole square term and we will be able to write it down as 1 minus of ax plus b plus a square x square plus b square plus 2abx, and this is equal to 9x square minus 9x plus 3. We just expanded using a plus b whole square formula. Now we will group in the left hand side all the constant terms together, all the coefficient of x together, and all the coefficients of x square together. So it is just a grouping now in the left hand side. So we have the constant terms as 1 minus b plus b square. Right, so I've taken this 1 minus b term here, and there is plus b square here. So all that I have grouped it together in one bracket. Then we will write down the coefficients of x. So if you observe, we have minus ax here, and we have plus 2ab into x. So plus 2ab minus a, the whole thing into x I can write. So 2ab minus a, the whole thing into x. And lastly, for coefficient of x square, we have only a square into x square. So plus a square x square. And this is equal to 9x square minus 9x plus 3. Plus 3. So what was the use of grouping down in this way is, now we can equate the coefficients of constants on both sides. We can equate the coefficient of x on both sides, and we can equate the coefficients of x square on both sides. So let us do that one by one. So we have I'll take first the coefficient of highest degree term on both sides. So we have a square is equal to 9. Equating the coefficient of x square on both sides, we obtain a square is equal to 9. So solving this, a is equal to plus or minus 3. Solving, we have obtained a values as plus 3 and minus 3. Now we equate the coefficient of x on both sides. So equating the coefficient of x on both sides, we can write it down 2ab minus a is equal to minus 9. Now we have two different values of a. So when a is equal to plus 3, we obtain 3 into 2, 6b minus 3 is equal to minus 9. So this gives us b value as, simplify. So we have minus 9 plus 3, which is minus 6. So b value in this case will be minus 1. So this is when a equal to 3. Now we take next value of a when a equal to minus 3. When a is minus 3, we have minus 6b plus 3 is equal to minus 9. And on simplifying, we will be getting minus 6b is equal to minus 12. So b is equal to 2. B is equal to 2 in this case. So thus our required values of a and b we have obtained. When a is 3, b is minus 1. So this is one set of a, b values for us. And when a is minus 3, b equal to 2 is another set of a, b values we have obtained. So therefore, we can conclude. Let us write down the conclusion now. Thus, a equal to 3, b equal to minus 1, and a equal to minus 3, b equal to 2 are the required values, required constants which were to be obtained. We'll take up the fourth question now. Fourth one. Let f, g, h be functions from R to R, where R is a set of all real numbers, where f of x is equal to x square, g of x is equal to x plus 5, h of x is equal to square root of x square plus 2. Show that H composition G composition F is equal to H composition of G composition F. So for the given data, that is for the given functions f, g and h, we have to prove that composition of functions is associative. In general, we have already proved the resultant in the very first problem itself, that composition of functions is associative. But for a particular functions which is given here, that is f, g and h, we have to prove that it is associative. So let us do the solution now. Since all the three functions f, g, h are functions from R to R, set of all real numbers to set of another set of all real numbers to set of all real numbers, all these three functions or the composition of these three functions will also be a function from R to R only. Right? So let us first consider for any element x belonging to the set of all relations, set of all real numbers. So let us consider h composition g of x. Consider H composition G of X, and that is given by H of G of X. H of G of X, and this in turn can be written as H of X plus 5. G of X is defined as X plus 5, so that is why we can write it down as H of X plus 5. Now, how is a h function defined? It is square root of x square plus 2. So, this in turn can be written as square root of x square plus 2. That is, here it is x plus 5 the whole square plus 2. X plus 5 the whole square plus 2. On expanding this, we can write it down. It is x square plus 25 plus 2x, 5 into 2, that is 10x plus 2 under the root. So this is one and the same as writing square root of x square plus 10x plus 27 plus 27. So this is h composition g of x. Now we consider the LHS of the same. So LHS will be h composition g composition f of x. And that can be written as h composition g of f of x. H composition g of f of x. We now first we took h composition g on the element x. There was a bracket in the LHS for h composition g. So first we considered h composition g of on the element x, and we obtained this. Now the entire LHS part we are considering, that is h composition g composition f. So we have h composition g composition f of x, that can be written as h composition g of f of x. So we will apply this now, h composition g on the element f of x. We have already obtained h composition g square root of x square plus 10x plus 27. On the function f of x, when we apply, we can write it down as square root of f of x whole square plus 10 into f of x plus 27 plus 27. And this is one and the same as writing, we know f of x is x square, so this becomes square root of x power 4 plus 10x square plus 27. So this is equation 1 for this. That is the left hand side, whatever we had, we considered it and we obtained square root of x power 4 plus 10x square plus 27 as the answer. Now on the same lines we will do with the RHS. When we observe the RHS, we have a bracket for G composition F. So first we consider G composition F on the element X and we obtain, then we consider the entire RHS and obtain the answer. So consider G composition f of x. G composition f of x. And that is g of f of x. G of f of x. So this can be written as g of x squared. Because f of x is x squared, this can be written as g of x squared. And since g of x is nothing but x plus 5, g of x square can be written as x square plus 5. X square plus 5. So this is g composition f of x for us. Now we consider the entire RHS. The entire RHS we consider. So that is nothing but H composition of G composition f of x is nothing but H of G composition f of x. H of G composition f of x from the definition of composition of functions. We have already obtained what is G composition f of x. This is nothing but x square plus 5. So let us substitute that. So this can be written as h of x square plus 5. And how is the h function defined? H function is square root of x square plus 2. So we will apply that now. So it is square root of x square plus 5 the whole square plus 2. So expanding a plus b whole square and simplifying. So square root of x power 4 plus 5 square is 25 plus 5 into 2 10x square plus 2. So this is x square whole square, which is x power 4, 5 square is 25, then 2ab term, that is 10x square plus 2 as it is. So this on simplification gives us square root of x power 4 plus 10x square plus 27 plus 27. So we'll call this as equation 2. Now observe 1 and 2. When we observe 1 and 2, they are the same expression. So we will be able to conclude that H composition G composition of F is equal to H composition of G composition F. So composition of functions is associative. So we will just conclude the same thing here. From 1 and 2, LHS is equal to RHS, which is the required answer for us. Hope you have understood these problems on composition of functions. Thank you for watching.